Okay, October 4th, 2011, we're going to take up question 2 from the homework last night. Question asks you what properties you would use to verify that a triangle has a right angle, which is a 90-degree angle. So, what we would do is we'll get our triangle, and I'm going to just rotate it a little. And let's imagine it's on the graph. I'm going to move it all over. So we have some triangle on the graph, and we need to verify that this is a right angle. Now, I may have drawn that little square in there, but that's technically not proof. I need to actually prove that this is a right angle triangle. So what that means is we'll call this one side A, okay? And we'll call this side B. These are both line segments. Line segment B and line segment A. I will need to find the slope of both A and B. So once I find the slope of A and B, what relation do the slopes have to each other in order to create a right angle, Renee?
They're going to be negative and one other one positive. They're going to be the same. Negative reciprocal. Yeah.
Negative reciprocal. So what that means is, I'm going to estimate here. Let's say that the slope of A is 1 over 2. This is an example. This is not proof. But if the slope of A was 1 over 2, in order for the corner of A and B, to be 90 degrees, the slope of B would have to be the negative reciprocal. So it would have to be negative 2 over 1. Okay? So two perpendicular lines have negative reciprocals as slopes. That's one property you could use. Call that the first one. A second property you could use is, you guys know Pythagorean's theorem, which is a squared plus b squared equals c squared. Well, if those are our lines A and B, we'll finally call the hypotenuse C. If I find the distance of A, B, and C, and I plug those numbers into this formula, and it is equal, then that means we have a right angle triangle. So the two ways we could have done this is, first of all, we find the slope of the two lines that create the 90-degree angle. So the slope of these two line segments, A and B. And if the slopes are negative reciprocals, then we know it's 90 degrees. Or I find the distance of line A, line B, and line C. And when I found the distance of all three, I plug them into this formula. And if it works out and everything's equal, then that means we have a right angle triangle, because this formula only works with right angle triangles. Question number 1 from your homework last night. They've given you a graph that looks like this. Point A is at 1 and 0, so that's our x and our y coordinate. And they've given us a line. They give us the equation for the line, but we don't technically know any of the points right now. We only know the equation of the line. But the other piece of information they've given us is that these two lines, line segment AB, this is point B, we don't know where it is, creates a 90-degree angle with this line, this equation of the line. So, we know our formula to be for linear equations, y equals mx plus b. I'm going to write out the equation. They have y equals negative 2x minus 2. So my m is equal to what? Negative 2 over 1. Good. Always try to keep a slope as a fraction. And b, negative 2. Okay? I could and draw the line perfectly, but this is just an example. So, we're using our numbers. I know that AB is perpendicular, creates a 90 degrees with this line. So now that I know the slope, line segment AB is going to be written in the same form. We're going to have another y equals mx plus b. I know what the slope of this line is going to be. The slope is going to be what compared to the other slope? Negative reciprocal. So the negative reciprocal, since this is already negative, our new slope is going to be positive 1 over 2. Okay? So that's our new m. So we're going to plug it in for the other equation. We get y is equal to positive 1 over 2x plus b. To find the equation of a line, we need slope and y-intercept. Right now, I'm working with 3 variables, y, x, and b. I need to solve for b. And it turns out I actually have information about this line. This line here touches point A. And I know what the x and y values of that point are. So since point A is 0, is it 1 and 0 or 0 and 1? Sorry. It is 1 and 0. That's an x value I can plug into the equation. And this is a y value I can plug into the equation to solve for b. So when I plug them in, y is 0 is equal to 1 over 2 times 1 plus b. All I have to do next is isolate the letter b. So I continue. 0 is equal to a half times 1 is a half plus b. I bring the half to the other side. I get 0 subtract 1 half is equal to b. b is equal to negative 1 over 2. So the equation of our line AB is y is equal to, here's our slope, 1 half x, and our y-intercept is negative 1 half. So this is the equation of our line segment AB. They just want the equation of the line.